Okay, so for this question, let's begin with the amplitude. Because one of the easiest thing that we can determine is the amplitude, yeah? So what's the amplitude for this one? Okay, amplitude is 3. What about the period? How do you get 4 pi? No, there's no 360 over here. 2 pi divided by half, and we get 4 pi. So we are expecting one complete cycle in 4 pi. But the range that we are required to draw for the graph is only up to 2 pi. So we are only getting half of a cycle. And knowing our sine graph looks like this for one complete cycle, then that implies that this is 2 pi and this must be 4 pi. In this case, with the maximum value as 3, minimum value negative 3. So fill in the other blanks, this is the x, and we do not require whatever is beyond 2 pi. So let us remove it. X, y equals to 3 sine half x. Alright? So 3C done. Question 4, anybody? For B. Sketch again for y equals to 4 plus 2 sine 2x. X is between 0 and pi. So we go through the same sequence again. What is the amplitude in this case? Cos B, what's the amplitude? What, 6, 4, 2, which one? 2. So the coefficient of your trigo is our amplitude. Now what is the period? Okay, I want the working period. How do we get it? 2 pi divided by 2. Okay, that is because we are using this 2 over here, which gives us pi. So we have one complete cycle in pi radian. So now our range is from 0 to pi. So how many cycles are we expecting to draw? How many cycles are we expecting to draw from 0 to pi, given that one complete cycle is pi radian? One only lah. Okay, one complete cycle takes pi. We only want to draw up to pi, that means it is one complete cycle. And we all know the shape of a sine graph. But there is a plus 4 over here. What does this plus 4 do to our graph? Okay, it changes the max and mean point, but collectively speaking, what does it do to the graph? Shift the graph up by 4 units. Alternatively, we can shift the x-axis down by 4 units. Okay, so that is the process that we'll be using. We are expecting one complete cycle, so 4 portions over here. 2, 3, and 4. Okay, this is my original x value. For my x-axis, draw our sine graph. Okay, so this over here we've got 2 pi, pi. Because everything is now half. So pi over 2 over here, pi over 4, and 3 pi over 4. The maximum value is 2, minimum value negative 2. Now instead of shifting the graph up by 4 units, I'm going to shift the x-axis down by 4 units. I'm going to use the blue color. If I were to shift it down over here, if I shift it down over here, how many units have I shifted? If I shift it down to this line, how much is it? See, this x-axis, I shift it down to this point. How many units have I shifted it down? 2 only. Enough or not? Not enough. Shift down some more. Another 2 units. So this is my new x-axis. Okay? So this being 0, what is this value now? What is this value? It now becomes 2. What is this value over here? 4. What is this value? 6. Now remove the old x-axis. Okay, finish. So you draw dotted lines over here to indicate that A, my minimum point is 2. My maximum point is 6. You can also draw dotted lines over here to show that the starting point and the end point, they both have a value of 4. Okay? Okay, any more from question 4? Any others? By the way, when you draw your graph, then the back of the answer of the textbook, no answer. How you check your work? You can ask, but that takes time. Just go Desmos and see it for yourself. Okay? Everybody has access to Desmos. Okay, question 5. Anybody needs help? No. Yes. Oh, okay. Yes. Okay, can extend. Let me think about it. Question 5. Anybody? Question 6. Anybody? If not, I'm going to call people already. This type of question one last time. Maximum value. We have to understand that fx over here will have different answers depending on the value of x. X is the variable. That's why we are plotting the graph of fx, which is commonly known as y, against x. As x varies, our value for fx changes. Now, a and b over here are constants. They are fixed already. We cannot change them. And that is what we need to find out. So, since I cannot change a, I cannot change b, and I say that fx depends on x, then the value of x is going to affect my value of cosine x. For different x, I get different values of cosine x. So if I want the maximum fx occurs when, fill in the blank, is blank. Okay, so what do you think goes into these blanks? This is your thought process. This is what must be going through your brain. So maximum fx occurs when? What do you think should go into the first blank? What do you think goes into the first blank? Cosine x. Okay, cosine x is 1. Okay, or rather maximum. Okay, because nothing else affects the value of fx when you know that a and b are fixed. So only thing that can change is x, which affects cosine x. If I want the largest fx, I naturally must have the largest cosine x. Because if cosine x is big, then fx is going to be big. If cosine x is small, fx is going to be small. You can see that from the equation. So now I want the maximum value of cosine x. What is the maximum value of cosine x? So that's where you need to be very familiar with the cosine x graph. Y equals to cosine x. What is this maximum value? What is it?
7.
Y equals to cosine x. What is the maximum value? 1. It can never go beyond 1. The minimum value, how much is it? Negative 1. So when it is maximum, it is equal to 1. Yes? The graph of y equals to cosine x. For our unit circle again, for any point over here, x and y, this being the radius, this being theta, cosine theta equals to, what is the value? Recap from your Emaths. X over r. Okay, what is the maximum possible value of x? In this case, your x can range on your x-axis over here, right? This point over here can shift. It can start from here, it goes all the way around the circle. As it travels one entire circle, what is the largest value of x? Are you sure it's 1? What is the radius of this circle? Look carefully. What is the radius? It is r. So what must be the largest value of x? How much is it? R. Largest value of x is r. That's the radius of the circle already. So largest x equals to r. Therefore, cosine theta equals to r over r, the maximum, which is 1. Alright? We cannot get anything larger than that already. You cannot draw a right angle triangle where we have cosine theta. This is our adjacent. This is our hypotenuse. You cannot draw a right angle triangle such that cosine theta is greater than 1. Because that would imply that if cosine theta is greater than 1, it implies that cosine theta is adjacent, right? So adjacent over hypotenuse greater than 1, which implies that adjacent greater than hypotenuse. Can you draw a right angle triangle with adjacent greater than hypotenuse? Cannot, because the definition is that hypotenuse is the side opposite the 90 degrees, which is the largest angle in a right angle triangle. You cannot give me an angle in a right angle triangle bigger than 90 degrees. You can try to draw as many triangles as you like. It cannot. Because if this is 90, then A plus B must be equal to 90, right? And none of them can be greater than 90. Then the hypotenuse is the side opposite the largest angle, because it's the longer side. Therefore, we cannot have adjacent greater than hypotenuse. Therefore, theta cannot be greater than 1. In other words, theta greatest value is 1. That happens when theta is equal to 0. When the angle is 0, then the adjacent value is x, or rather in this case r, divided by r again, which is 1. Then the minimum value happens over here. This is the minimum value when you have sine. No, are we talking about cosine? We are talking about cosine. Cosine 180 degrees. We will get negative 1. Sorry, in this case, negative r over r. So negative 1, no? Okay, Cosby? Okay, so maximum value of cosine x. All of you must be able to tell me, what is the maximum value of cosine x? How much? All say together, come on. Maximum value of cosine x is 1. Minimum value of cosine x is? Okay, maximum value of sine x is? Okay, 1. Minimum value of sine x is? Why you are not sure? What is the minimum value of sine x? Negative 1. We just need to draw the graph and we know it. This is 1, this is negative 1. This is for y equals to sine x. Okay, so back to the question. Maximum fx occurs when cosine x is maximum, which means that cosine x is equal to 1. Therefore, we substitute in values. Maximum value is 7. 7 equals to a times 1 plus b. This is my first equation. Second equation, I want the minimum value. So substitute inside here. 3 equals to a times, what is the minimum value of cosine x now? Negative 1 plus b. Solve simultaneous equation. Sec 2 student can do. You sure can do. Okay? Equals to?
Maximum plus minimum over 2.
And then, what do we get?
Yeah, equal to 5. A.
Oh, then?
Get 5. You don't really need to do something simultaneous.
Yes, you can do that also. Okay, next one. Question 6. Who needs help with question 6? Raise your hand, otherwise I'm going to call people already. Who else needs question? Who needs question 6? Nobody. Who is number 1 on the register?
Angel.
Huh? Angel, okay. Question 6, tell me how I should start. Maximum value is? Okay, then. Okay, then. 10. Equals P sine. Okay, sine P sine -4. Okay, let's try again. 10 -4 sine Let's try again. 10 equals to P plus Q. What happened to your sine x? What happened to your sine x? So what happened to your sine x? So put down the 1 over here to show that, yeah, it happens when sine x is equal to 1 for the maximum value. And this is equation number 1. Okay, continue. -4 equals P plus 1, P minus 1. So like that, P minus 1. Times -1 plus Q. So second equation. Solve. Yes, this is correct. So now I'm going to do a recap on our modulus. All look at the screen, stop doing your homework. Look up, look up, look up. Okay, we've got this again. Y equals to modulus x. Alright, what are the possible values of x in this case? Can x be negative? Listen carefully. Can x be negative? Yes, it can be negative. Can x be 0? Yes or no? Yes, it can be 0. Can x be positive? Okay, let's work with some numbers. When x equals to -1000, y equals to modulus of -1000 to give us 1000. When x equals to 0, y equals to modulus 0, which gives us 0. When x equals to 200, y equals to modulus 200, which gives us 200. So this is how modulus works. Whatever is negative, it becomes positive. The magnitude stays the same. So then we saw that graphically, if I have a graph of y equals to x this way, and I want a graph of y equals to modulus x. So you see this portion over here is positive x region. This is the negative x region, right? In our calculations over here, what happened to positive x values? Do they stay the same? Stay the same. So for our graph of y equals to x versus y equals to modulus x, the positive region stays the same. No change. But what about the negative region? See, when it is supposed to be -1000, then the y value becomes 1000 instead of -1000. Similarly for all other negative x values. So let's say this is our value -1000. In our y equals to x, this will be negative 1000 as well. But with the modulus sign, this y value of negative 1000 becomes positive 1000, which is over here, 1000. Same distance as this. Okay? So this particular point is now shifted up to this point. We do the same for everything. We will get a reflection this way. So whatever is at the bottom is now reflected upwards. Then we dot or we erase the graph at the bottom, and now we end up with the graph of y equals to modulus x. The value 0, x value 0 wasn't affected, just like positive values. So we've also got y equals to, for example, x squared plus, okay, not plus, minus 3. If you are told to sketch this graph, how will you go about doing it? Okay, what kind of graph is this? Parabola opening upwards, okay? We are going to get this shape. We are going to sketch the graph of y equals to x squared first. This is the graph of y equals to x squared. But I want a graph of minus y equals to x squared minus 3. What should I do with the graph? Move the graph up or down? X squared minus 3 then. I move the graph down by 3 units. Alternatively, I move the x-axis up by 3 units. So I'm going to move this up by 3 units. So there are now 2 intersection points. Okay? What is now the minimum value? Originally, minimum value was 0. So what is now the minimum value? Negative 3. Okay, then you must also have these 2 values, which you can find out for yourself. What are they? What is the positive value over here? When y equals to 0. Come on. No, not 3. Square root 3. Then the other side must be negative square root 3. It's symmetrical. But now, instead of this graph, I want modulus. So which part of the graph changes? Below x-axis changes. How does it change? Gets reflected along the x-axis upwards. So now we move this point up. Okay, what is this value over here now? What is this maximum point? 3. So now we have to dot. We dot the regions that we don't require. Okay? So now I have a graph of y equals to modulus x squared minus 3. Okay?
Wait, so much present it this way.
Yeah lah. Okay, now I'm going to make one more change. What happens if I have y equals to modulus x squared minus 3 plus 1? What happens to this graph? What happens to the existing blue graph?
It's moved down. The x-axis can move down by 1.
Okay, wait. Blue graph, what happens to it? Up or down? Up. It shifts up by 1 unit. Do you really want to draw this graph again? So what should we do?
Move the x-axis down by 1 unit.
Move the x-axis down by 1 unit. So if this is negative 3, then 1 unit will be over here. This is my new x-axis. Then I'm going to remove this point, this x original one. And now this is my new graph. So let's adjust all the important points. Earlier on, we said that this point over here was negative root 3. It stays as negative root 3. This one is still, this minimum point over here is still positive root 3. Then this point over here, does it still remain as 3? No, my x-axis shifted down, so that value must increase, right? Become 4. So now this graph is a plus 1 graph, okay? So when you are given this graph, this equation to sketch, you must know the sequence. First, we draw the x squared. Then I include the minus 3. Then I do the modulus. Then I do the plus 1. Are you able to figure out this sequence by yourself? It is similar to the Bodmer's which we have learned in primary school. Your brackets, then your all those things. You must know the sequence. Okay, so now we're going to apply all this to our modulus, trigo. The first one we have work example 15. Sketch the graph of y equals to sine x, modulus sine x, for the domain, in other words for the range, x between 0 degrees and 360 degrees. Which unit are we using in this question? Degrees. Okay, so in order to sketch this modulus graph, what should we sketch first? Sketch y equals to sine x first. So all must be experts. Okay, sketch on the side of a graph or your textbook right now. Very quickly. It is always these few shapes. Okay, so this is the graph of y equals to sine x. And if I want the modulus graph, which portion must be removed? Negative portion. Oh, I didn't include the maximum minimum values. This is 1, this is -1. So the portion under the x-axis must flip up. Then when you flip up, the minimum point will become a maximum point, and it has the same y value. Okay, so you must draw it very clearly, show that you know it has a maximum value of 1. So we're going to erase the reflected portions at the bottom. So we're done with the graph. Y equals to modulus sine x. So the next part is find the range of values of y. So this is my y-axis. For my new graph, what is the minimum value now? Minimum value is 0. So y ranges from 0. What is the maximum point? 1. Compare this with our y equals to sine x. My y ranges from -1 to 1. Okay? So what are the angles that result in a value of 1? According to this new graph. What are the angles that gives you a y value of 1? 90 and? Look carefully. What are the values? 90 and 270, yes. Okay, compared to y equals to sine x, we only have one value over here. Y equals to 1 when x equals to 90. Okay, practice now 15. Question 2. Question 1 too simple already. Let's do question 2. Okay, so we are supposed to do only y equals to modulus 2 cosine half x for 0, that's the minimum value, x up to 2 pi. So same sequence. What is the amplitude? What's the amplitude? 2, period, equals to 2 pi divided by half, which is 4 pi. So from 0 to 2 pi, do I get one complete cycle? How much of a cycle do I get? Half of a cycle. So I now want to draw my graph of 2 cosine half x first. Break it down into the same usual 4 parts, y and x. 2 cosine half x. So if I want to draw a full cycle, This will be the scale required to extend for the x-axis for one full cycle. Cosine, so we start from here. Okay, so now I have the maximum value of 2, minimum value -2. Y equals to 2 cosine half x. But did I draw extra? Yes, right, so I need to erase. I erase from anything beyond 2 pi. Because the question says until 2 pi only. So erase all this. This is not important anymore. I also don't need my x-axis to be so long. So let's just stop over here. X. Okay, so this is an important point. This value is -2. So now I need to include the modulus. Anything below x-axis, flip it up. When you flip it up, this point stays the same. The minimum point is now reflected up over here. Then the question is, how good is your imagination, visually? Is it going to give you this shape? Is this a reflection? No. It is a reflection, okay. So, oops. Is this a good reflection? Look closely, is this a good reflection? No. Still can improve? How about this? Cannot be lah. Okay, how about this? Better? Okay, let's make it just a bit better. Okay? So it looks like a bird. That's the answer. For the range that is required. Now what happens if you draw extra? You may be penalized. So state the range of values of y. Y ranges from, what's the minimum value of y? What's the minimum value of y in this case? No, it's not -2. 0 until 2. Done. Okay, next question. Work to example 16.
But I can do modulus then modify this.
Okay, now class. For work example 16, my focus is not on the graph sketching, but it is a recap of a skill that you learned in Sec 2. How you create a graph to solve an equation. Okay, so in our textbook, they have already given you the graphs of y equals to tangent x, modulus, tangent x, and y equals to cosine x. These two graphs are drawn already. Okay, then if you look over there, there are some intersection points. Now, they want you to state the number of roots of the equation. To find number of roots for tangent x equals to cosine x for the range of 0 to 2 pi. To find the number of roots for this equation, we are trying to find the number of intersection points. To find number of intersection points. For the graphs, okay, what are the two graphs? We are supposed to find the intersection points for two graphs. What are the two graphs over here? First one, y equals to modulus tangent x. Second graph is y equals to cosine x. Okay, because if we were to solve these two equations simultaneously, if we solve them simultaneously, we will obtain tangent x equals to cosine x, which is what is required in the question. So the number of intersection points will give us the number of solutions. Based on the graph, there are 2 points of intersection, so 2 roots. Okay? What if the question is in practice now 16? Question 2. Okay, sketch the graph of y equals to modulus tangent x, assuming we already have that, as well as y equals to 1 plus cosine x. Then they want you to find the number of solutions for tangent x modulus equals to 1 plus cosine x. So number of roots, what shall we do with our two graphs? Sketch both lah, okay? Sketch y equals modulus tangent x, y equals 1 plus cosine x. Number of intersection points equals number of roots. Okay? Simple. Work example number 17. Also the same type of question, but there's a slight change. We've got y equals to modulus cosine x graph, as well as y equals to 2x over 5 pi. Then they want us to find the number of solutions for 2x equals to 5 pi cosine x. Number of solution. Then how? This doesn't look like the graphs we already have. How? Should we then sketch y equals to 2x and also the graph of y equals to 5 pi modulus cosine x? Should we sketch both? Then what's the easier way? Why should we use our existing two graph? How and why we can do that? Why and how? Reason is because I can manipulate this equation to what I currently have, the graphs I currently have. So you don't have to draw the graphs again. Can I form a cosine x modulus by itself? Can, right? So I've got cosine x modulus equals to 2x over 5 pi. So if I draw the graph of y equals to cosine x, and I draw the graph of y equals to 2x over 5 pi, then the number of intersection points, the solutions, will be the solutions for this equation. And then you ask yourself, do you already have these two graphs? Yes lah, the question already asks you to draw. Okay? So you know your homework questions. Please finish it up. Exercise 8b.